Imagine you are standing beneath a night sky thousands of years ago. There are no cities, no electric lights, no engines, no steel towers rising above the horizon. Only darkness, firelight flickering against stone. And somewhere beyond the edge of the camp, something falls from the sky. A streak of light tears across the darkness. For a few seconds, the entire landscape glows. Then silence. The people watching have no idea what they just witnessed. They don't know about asteroids. They don't know about planets. They don't know that the glowing object has traveled through space for millions of years. But perhaps, days or years later, someone finds a strange blackened stone lying in the ground. It looks like a rock, but it is different, heavier, colder. And when it is struck, it doesn't crumble like ordinary stone. It can be hammered. It can be shaped. It can become something beautiful, something sharp, something almost magical. This may have been humanity's first encounter with iron. Not iron ore buried in the earth, not a furnace, not a mine, but metal from the heavens. And that distinction matters, because ancient humans did not simply wake up one morning and decide to invent the Iron Age. Iron had to be discovered in stages. First, people had to encounter metal that already existed in metallic form. Then they had to learn how to shape it. Then, much later, they had to discover one of the most difficult secrets in ancient technology. How do you take a dull red rock and turn it into metal? The answer would transform farming, warfare, trade, kingdoms, and eventually civilization itself. But getting there would take thousands of years, and it would begin with something falling from the sky. Long before humans learned to extract iron from rocks, iron was already appearing in a form they could actually use: meteorites. Some meteorites contain large amounts of iron and nickel, and unlike most iron found naturally on Earth, meteoritic iron can exist as actual metal. That makes it incredibly unusual. Imagine being a Stone Age hunter and finding a piece of it. You don't have a periodic table. You don't know what an alloy is. You don't know what oxidation means. You simply know that this strange material behaves differently from stone. You strike it, it dents. You strike it again, it changes shape. The discovery would have been extraordinary. Archaeologists have found evidence showing just how early humans were experimenting with this strange material. In Egypt, 9 small iron beads from the cemetery at Gerzeh have been dated to roughly 3200 BC. Scientific analysis showed that the iron came from a meteorite. The ancient craftspeople had hammered the metal into extremely thin sheets and rolled those sheets into tubes to create beads. Think about what that means. These people lived thousands of years before the great Egyptian pyramids. They did not have an Iron Age industry. They did not have armies carrying iron weapons. Yet they were already working with iron. And the iron was precious enough to be worn as jewelry. It was placed alongside other valuable materials: gold, carnelian, exotic stones. The metal from the sky was not ordinary. It was something rare, something mysterious, something that could not simply be collected from every riverbank. To possess it was to possess something almost otherworldly, and perhaps that is exactly how ancient people understood it, because from their perspective, where else could metal like this have come from? This is where the story becomes surprising. When we hear the words Iron Age, we often imagine ancient people surrounded by iron swords, axes, shields, and tools. But that came much later. For thousands of years, humans were perfectly capable of living without iron. Stone was everywhere. Copper could be collected and worked. And eventually humans learned to combine copper with tin to produce bronze. Bronze was revolutionary. It could be cast. It could be shaped into weapons. It could be turned into tools. And entire economies developed around obtaining the materials needed to make it. Iron, by comparison, was difficult. The problem wasn't that iron was rare in the Earth's crust. Quite the opposite. Iron is extremely abundant. The problem was getting it out. Most terrestrial iron is locked inside minerals. The metal is chemically bound to oxygen and other elements. So if an ancient person picked up a reddish rock containing iron oxide, they weren't holding a piece of iron. They were holding something that had to be transformed. And that transformation required heat, fuel, air, knowledge, and an extraordinary amount of experimentation. The first person who solved that problem didn't simply discover a new metal. They discovered how to change the earth itself. Imagine an ancient craftsman standing beside a fire. Perhaps they are already working with copper. They know that certain rocks produce strange materials when heated. They know that charcoal burns differently from ordinary wood. They understand that some fires become hotter when air is forced into them. They don't have the scientific language to describe any of this, but they have something more important: experience. Generation after generation, people had been learning how fire behaved. They knew that certain stones cracked when heated, others changed color. Some produced shiny droplets, some produced nothing at all. And eventually, someone noticed something strange. A rock that looked worthless before the fire could become something else after it. Perhaps the first successful experiment was an accident. Perhaps it happened inside a furnace already being used for another metal. Perhaps a craftsman noticed tiny metallic particles trapped inside the waste. We cannot point to one individual and say, this was the person who discovered iron. The archaeological evidence doesn't give us that story. Instead, it shows a long process of experimentation and development across different regions. That is important. The discovery of iron was not one dramatic moment. It was a technological evolution. And one of its most important steps was learning that iron could be extracted from ore. But there was a problem. Iron is stubborn. You can't simply throw iron ore into an ordinary campfire and expect a sword to appear. Ancient iron production generally relied on furnaces that used charcoal and controlled airflow. Inside these furnaces, the chemistry was doing something remarkable. The charcoal was not merely providing heat. It also helped remove oxygen from the iron-bearing minerals. Instead of melting the iron completely into a pool of liquid metal, early furnaces often produced a spongy mass of iron mixed with slag. This mass became known as a bloom. The bloom was not beautiful. It wasn't a shiny bar. It was more like a dirty, glowing lump packed with impurities. And the work wasn't finished. The blacksmith had to heat it again, and hammer it, again and again. Every strike forced slag and other unwanted material out of the developing metal. What emerged was wrought iron. The process sounds simple when explained in a few sentences, but imagine doing it without thermometers, without chemical analysis, without industrial furnaces, without machines. You are controlling a fire by watching its color, listening to its sound, feeling its heat, watching the charcoal, adjusting the airflow, judging the ore, judging the furnace, and hoping the material inside has transformed in the way you expect. One mistake could ruin hours of work. One poorly controlled furnace could produce almost no useful metal. Ironworking was not just a discovery, it was a conversation with fire. The furnace technology that made this possible is commonly associated with the Bloomery process. A bloomery could be built from clay, earth, or other heat-resistant materials. Iron ore and charcoal were loaded into the furnace. Air entered through openings, blowpipes, or later systems involving bellows. As the charcoal burned, the furnace created the chemical environment necessary to reduce iron oxides. The iron formed as solid metallic particles rather than as a giant pool of molten metal. Eventually, a bloom accumulated. The furnace was opened, the glowing mass was removed, and the real work began. Hammering, heating, hammering again. The metalworker was essentially cleaning the iron by force. The Historical Metallurgy Society describes the bloom as a porous mass containing iron and slag that required consolidation and forging before becoming useful wrought iron. This is one reason ancient ironworking was so demanding. You weren't simply making metal, you were repeatedly rescuing it from the waste surrounding it. And every successful attempt taught the craftsman something. How much charcoal? How much ore? How much air? How long should the furnace burn? What kind of ore works best? What temperature produces the best bloom? The answers could be passed from one generation to another. That is how technology spreads. Not through textbooks, through memory, through apprenticeship, through watching someone's hands. Sometimes the iron didn't behave exactly as expected. The amount of carbon entering the metal could vary, and carbon changes iron dramatically. With the right conditions, you can produce steel. Not modern stainless steel, not the perfectly controlled alloys produced inside modern factories, but carbon-containing iron that could become much harder than ordinary wrought iron. Ancient metalworkers did not understand carbon at the atomic level. They didn't need to. They could discover its effects experimentally. One blade might bend, another might hold an edge, one piece might crack, another might become exceptionally hard. The craftsmen who understood the difference had an advantage, and eventually, generations of experimentation turned what had once been a mysterious metal into a specialized technology. Ironworking was becoming a craft, and craftsmen were becoming dangerously valuable. There is another reason iron changed history. Bronze depended on a special combination of materials. Copper and tin had to be obtained, and tin was not available everywhere. This meant ancient societies often depended on long-distance trade networks. Iron was different. Iron ore existed in many regions. The challenge was not finding iron-bearing rock. The challenge was learning how to process it. Once communities mastered that process, they could potentially produce iron using locally available resources: ore, wood, charcoal, clay, labor, knowledge. That changed the economic equation. A society didn't necessarily need to depend on distant sources of tin in the same way. But there was a catch. Iron production consumed enormous amounts of fuel. Forests became resources. Charcoal became essential, and ironworking could become an industry involving miners, charcoal burners, furnace builders, transporters, smelters, and smiths. The metal might be abundant in the ground, but turning it into useful objects was anything but cheap. Another common myth is that the moment humans discovered iron, bronze weapons became obsolete. That didn't happen. For a long time, iron was rare and valuable. People continued using bronze. In some places, iron objects were prestige goods. In Egypt, for example, iron artifacts existed long before iron became a common material. One of the most famous examples is the dagger buried with Tutankhamun. Modern scientific analysis established that its blade was made from meteoritic iron. It was not evidence that ordinary Egyptians had mass-produced iron weapons. It was evidence of something much more interesting. Humans could value iron long before they could mass-produce it. The distinction matters. There is a huge technological gap between finding a meteorite, hammering it into a blade, and building a society capable of producing thousands of iron tools. The first is craftsmanship. The second is industry. And humanity had to cross that gap. Eventually, iron production became more reliable. Furnaces improved. Airflow improved. Craft knowledge accumulated. Ironworking traditions developed across different regions, and iron objects became increasingly common. Now imagine what happens when a village suddenly has access to durable iron tools. An iron axe can help clear woodland. An iron hoe can improve agricultural work. Iron knives can be sharpened repeatedly. Iron nails can join structures. Iron weapons can be produced in greater quantities. The impact isn't limited to warfare. It reaches the farm, the forest, the workshop, the road, the household, the battlefield. A new metal has entered almost every part of life. And that is when the Iron Age becomes more than a story about weapons. It becomes a story about production. Picture a farmer standing at the edge of a forest. For generations, his community has used stone and bronze tools. Now he has an iron axe. It isn't magical. It isn't indestructible. But it can be repeatedly forged and sharpened. He swings. Wood chips fly. Again. Again. The tree begins to weaken. A tool that once required enormous effort now makes certain tasks more practical. Multiply that across hundreds of people, then thousands, then generations. More land can be cleared. More fields can be cultivated. More settlements can grow. Of course, iron alone did not create agricultural expansion. Climate, population, animals, land, social organization, and countless other factors mattered. But technology can change what people are capable of doing. And iron gave communities another powerful tool. The metal had moved from the sky into the soil, and now into the hands of farmers. There was another place where iron mattered enormously: war. Imagine an army where metal weapons are expensive. Bronze is valuable. Weapons must be repaired. Supplies depend on trade. Now imagine a society developing a reliable ironworking tradition. The balance begins to change. Iron weapons can become more widely available. Swords, spears, knives, arrowheads, axes, armor components. The exact timeline and impact varied enormously from region to region. Iron did not automatically make one army invincible, and an iron weapon was not necessarily superior to every bronze weapon. But as production expanded, iron became increasingly important. And eventually, the material that had once been mysterious and rare became one of the foundations of military power. The metal from the sky had become the metal of armies. But there is something we often forget. When we talk about ancient iron, we imagine the warrior, the sword, the spear, the king, the battlefield. But behind every iron weapon was an enormous chain of human labor. Someone had to find the ore. Someone had to extract it. Someone had to carry it. Someone had to cut trees. Someone had to turn wood into charcoal. Someone had to build the furnace. Someone had to operate the bellows. Someone had to maintain the heat. Someone had to remove the bloom. Someone had to hammer it. Someone had to shape the final object. And someone had to learn all of this from somebody else. Ironworking was a social technology. A single blacksmith did not create the Iron Age. Communities did. Now close your eyes. Listen. First, the crackling of charcoal. Then the roar of air entering the furnace. The hiss of hot metal. The hammer coming down. Clang. Silence. Another strike. Clang. Sparks explode into the darkness. The craftsman turns the glowing metal. Another strike. Clang. The smell of smoke fills the air. Sweat runs down his face. His arms ache. But the lump of dirty iron is changing, slowly. A shape is emerging. The material that began as stone is becoming a tool, and the tool may outlive its maker. It may be buried with someone, lost beneath a settlement, dropped in a field, recovered centuries later. And when archaeologists eventually find it, they see only a small object. But behind that object is an entire world: the mine, the forest, the furnace, the charcoal, the knowledge, the labor, the fire. This is where history becomes complicated. For a long time, people wanted a simple answer. One civilization discovered iron. Everyone else learned from them. But ancient technology rarely spreads in such a neat line. Iron smelting developed and spread through different regions, and archaeologists continue to debate the exact origins and pathways of early iron production. There is strong evidence for early ironworking traditions in the eastern Mediterranean and surrounding regions. There is also evidence for independent or locally developed traditions elsewhere, including Africa and South Asia. That means we should be careful when telling the story. There may never have been one ancient genius who suddenly invented iron. Instead, humans in different places were confronting similar problems. They had iron-rich rocks, they had fire, they had charcoal, they had furnaces, and they had curiosity. Different communities may have discovered similar solutions independently. Others may have learned from neighboring societies. Some technologies may have traveled with migrating craftsmen. Others may have been reinvented. The Iron Age was not a single invention spreading like a light bulb being switched on. It was more like thousands of fires appearing across a dark landscape. Some went out. Others survived. Some grew larger. And eventually, they changed the world. Here is the strangest part of the entire story. Humans didn't really discover iron. Iron was already here. The earth was filled with it. The real discovery was learning how to free it. That required understanding something ancient people could not see: oxygen. Iron ore is chemically bound with oxygen. The furnace had to create conditions that pulled that oxygen away. The charcoal was part of the solution. Heat was part of the solution. Airflow was part of the solution. And the craftsman had to bring all of these elements together at exactly the right time. In a sense, ancient metalworkers were performing chemistry without knowing the word chemistry. They were manipulating invisible processes using visible clues: color, smoke, fire, texture, sound, weight. The technology was empirical: try, fail, remember, try again, and eventually succeed. Think about how far that journey went. A piece of metal falls from the heavens. Someone finds it. Someone hammers it. A strange bead is created. Thousands of years later, other people experiment with iron ore. They build furnaces. They burn charcoal. They create blooms. They hammer away slag. They discover stronger forms of iron. Blacksmiths refine their techniques. Farmers receive stronger tools. Warriors receive new weapons. Kingdoms develop new industries. Trade networks change. Military technology changes. And eventually, iron becomes so common that modern civilization is almost impossible to imagine without it. Today, iron surrounds you. It is hidden inside buildings, bridges, machines, vehicles, tools, railways, ships, factories. And beneath modern steel is the same basic material that ancient humans once struggled to pull from a furnace. The difference is scale. Modern industry can control temperatures with extraordinary precision, analyze chemical composition, move enormous quantities of ore, produce millions of tons of steel. Ancient craftsmen had none of this. They had fire, stone, wood, charcoal, clay, hands. And knowledge passed from one generation to the next. It is tempting to remember the Iron Age through weapons. The sword is dramatic, the spear looks powerful, the axe feels primitive and dangerous. But the real revolution was quieter. It was the ability to transform a material that existed everywhere into something useful. That skill could be applied again and again. A farmer needed an axe. A carpenter needed a chisel. A builder needed nails. A hunter needed a knife. A warrior needed a spear. A craftsman needed tools. A society needed infrastructure. Iron could answer all of these needs. That is why metallurgy matters. A technology becomes truly transformative when it stops being a curiosity and becomes part of everyday life. Somewhere thousands of years ago, an ancient person looked at a strange stone and saw possibility. Maybe they didn't understand what they were seeing. Maybe they were simply curious. Maybe the first successful experiment was an accident. Maybe the knowledge came from generations of failed attempts. We will probably never know. There are no surviving notes from the first iron smelter saying, "I discovered this today." No ancient laboratory notebook, no name, no photograph. Only traces, furnace remains, slag, corroded tools, tiny metal fragments, buried objects. And sometimes, a bead made from metal that fell from space. These fragments allow us to reconstruct a story that is thousands of years old. A story about people who experimented with materials long before modern science existed. People who learned by observing. People who failed. People who tried again. People who eventually discovered how to make the Earth surrender one of its most important metals. There was no morning when humanity woke up and suddenly entered the Iron Age. For generations, bronze and iron existed side by side. Some societies adopted ironworking quickly. Others continued using bronze extensively. Some iron objects remained luxury goods. In other regions, iron eventually became a practical material for everyday tools. The transition was uneven, it was messy, it was local, and it took time. That's what makes the story more fascinating. Human progress rarely happens in a straight line. A technology can be discovered and then forgotten. A technique can exist in one village while another community has never seen it. A craftsman can invent a better method and take the secret to his grave. A kingdom can collapse and destroy an entire production network. Then, centuries later, another society can rediscover a similar solution. History is not a staircase, it is a maze. And iron was one of the greatest technological mazes humanity ever entered. Now imagine you are standing in front of an ancient furnace. Inside it is a mixture of charcoal and ore. The fire is roaring, the walls are glowing. You have spent hours feeding it. You don't have a thermometer. You don't know the exact temperature. You don't know whether the experiment will work. You open the furnace. A glowing mass emerges. It looks like a disaster. Rock, slag, metal, ash, everything mixed together. Would you throw it away? Or would you pick up your hammer? Because that decision might be the difference between failure and the beginning of a new technology. You strike it. Clang! A piece of slag breaks away. You strike again. More falls off. Underneath, there is metal. Real metal. Something that can be shaped. Something that can be sharpened. Something that can survive repeated use. You may not understand the chemistry. You may not understand why it worked. But you know one thing. You have discovered something. And tomorrow, you will try it again. Thousands of years later, we live in a world built from the consequences of that discovery. Iron became steel. Steel became railways. Bridges, ships, factories, skyscrapers, cars, machines, modern infrastructure. The industrial world depends on metals that ancient people could barely imagine producing. But the first step was incredibly small. A strange piece of metal, a hammer, a fire, a person willing to experiment. And perhaps, long before anyone understood how iron could be smelted from ore, there was another moment. A moment when someone looked upward and saw a burning object cross the sky. They didn't know that the metal inside it had been forged in the violent history of the solar system. They didn't know that iron would eventually become one of humanity's most important materials. They only knew that something strange had fallen from the heavens. They picked it up, and for the first time, humanity held iron in its hands. Not because we had conquered the earth, but because the universe had delivered a piece of itself to us. And thousands of years later, humans would learn something even more extraordinary. We didn't need to wait for iron to fall from the sky. We could make the earth give it to us. That was the true beginning, not the first sword, not the first army, not the first kingdom. But the moment humans learned to look at ordinary stone and see metal hiding inside. Because once humanity learned that trick, there was no going back. The stone beneath our feet was no longer just stone. The fire was no longer just warmth. And the earth itself had become a source of power. The Iron Age was born from that realization. A realization made by people whose names we will never know. People who had no laboratories, no machines, no equations. Only fire, patience, and the courage to try again. And perhaps that is the greatest lesson hidden inside the story of iron. Human civilization was not built by people who already knew the answers. It was built by people who were willing to ask what would happen if they tried one more time. If you learned something new today, please smash that like button. It really helps the channel. And if you want to see more videos just like this one, go ahead and hit subscribe and turn on the notification bell so you never miss an upload. Thanks so much for watching, and I'll see you in the next one.